Good morning to all. Today we are going to start the new topic, that is composition of two functions. The name suggested, composition means it is a mixture of two functions. After that we will come the questions which are related to invertible functions. Now the questions, first of all, what is composition function, that we have to understand. Now the name is composition of two functions, means it is a mixture of two functions, and so many questions will be there from this topic. So just it is also an important part of function. Now composition function is what? Suppose let f is a function from a to b and g is a function from b to c are two given function. Here f is one function which is from a to b and another function is g which is from b to c are two given functions. Then the function, then the composition of f and g is denoted by f and g denoted by GOF. This is called G circle F. It means it is the mixture of two functions. What the functions are? One is f and other is g, and combination of two function f and g is denoted by G circle F. Okay, and is defined, denoted by GOF, is the function defined by GOF is a function from a to c such that GOF of x is equal to g fx, and for all x belongs to R, sorry, A. Very simple. Just see what it is. Here one point is there, f is a function, means two function, one is f and other is z, and when we mix these two functions, the function is denoted by G circle F, that is called GOF. G circle F means GOF. GOF is a function which is a mixture of f and g. See, the domain of the first set is what? A, and second set is B, but for G, first set is B and other set is, second set is C. Then GOF is defined from A to C. You see it as a diagram. See, here it is. One is A, other is B, and this is C. So one function f which is from A to B and another function g which is from B to C. Then a function from A to C is called GOF, means f composition G circle F. This is GOF. Just see again. F is a function which is from A to B and G is a function which is from B to C. Then the function which is from A to C is called GOF. This means f composition G, and we can say it as G circle F. This is GOF, and GOF is also a function, means what do we observe? When two functions are there and when we mix, then the answer is, the resultant is also a function. That function is from A to C. See, if x belonging to this set, then f of x belonging to this set, that is denoted by y, some. Okay, and now if y is belonging to this set B, and this is called g of y, here it is x and this is f, then this is called fx. Image of x is fx, and if it is g is a function from B to C and y belonging to this set B, then this is called g of y. Now this g of y can be written as y, in place of y we write f of x. So if A is contain x, then C contain g f of x. Now one function is from A to C. Don't take it as a composition. Just you see a function which is from A to C is denoted by gof. Suppose in place of gof if I write h, means h is a function which is from A to C and x belonging to this set, then this is called what? H of x. So h of x means what? H means what? Gof. So gof of x. So it means gof of x is equal to g f of x. Gof of x equal to g f of x. Clear? So it is what? It is a composition of two functions. One function is f, which is from A to B, and a second function is g, which is from B to C. Then a function which is from A to C is denoted by gof. Then if x belonging to the set A and y belonging to set B, then the value of y is f of x. And if here you can say z belonging to C, then what happened? G of y is equal to z. So g of y equal to z, then y, in place of y we write fx. So the value of z is g f of x. And here also, if A is set A contain x, set C contain z, then in place of gof if I write h, so h is a function from A to C, then h of x is equal to z, and both having z. So go, and in place of h we write gof. So gof of x equal to g f of x. So that is why I written gof of x means g f of x. So this is the composition of two functions. Now you see one more thing. Domain of f is what? A. Domain of f is set A. Range of B, range of f is f of x, that is B. This is fx. So what we write? Set A is domain of f. Range, we can say it as domain of f is set A, and domain of gof, this is gof, is also A. Means if from where f is started, that same gof is also starting from this set A. So both having same domain. And now what is the range of G? This is this set, the images of this set, that is g of y. So range of gof is same as range of, we can write in this way, this side, domain of f is equal to domain of gof, and range of G is equal to range of gof. Okay, again, when gof is defined only when gof is defined only when range of f is a subset of domain of G. So range of f is range of F is a subset of domain of G. So range of F is a subset of domain of G means what? Range of F. This is a range of F. It should be the domain of G. So if it is there, then only GOF is defined. Clear? One more. Again you see in different way. I will try to. I want to explain that thing. Composition function again. Here it is. F is a rule from A to B and B to C. H is a rule, G is a rule, and A to C is denoted by H. Okay. So if I take it as X, then this is F of X and Y is here. So Y equal to F of X, and here it is Z. So G of Y is taken as Z, and this equal to Z equal to what we write? Z equal to G and place of Y Fx. Okay. Now A to C is H. So Z equal to H of X, and this H of X equal to G. See, both having Z. So H of equal to H of X equal to what? G F of X. And now this H means A to B, F is there, B to C, G is there. So A to C, that is H. So in place of H, we write GOF. This is what? GOF. H means what? H is a composition of F and G. F and G is denoted by H. So GOF of X equal to G F of X. Similarly, if I write fog of X, then it is F G of X. Okay. So this is what? Composition of two functions. So two things very important. Domain of, again, domain of F is equal to, in for GOF. First is GOF. GOF, it is a function from A to C. GOF is a function from A to C such that G Fx equal to G of Fx, and domain of F is equal to domain of GOF. Okay. Range of F is range of G is equal to range of GOF. These all are the things related to GOF only. When GOF is defined, GOF is defined only when range of F is a subset of domain of G. So this whole thing which are related to GOF. So when it is fog is defined only when range of G is a subset of domain of F, and domain of G is equal to domain of fog. This is called F circle G, and range of f is equal to range of fog. This is called fog and previous one is called Goff. See, G circle F, this is called Goff. G circle F means Goff, and it is a composition of F and G, and fog is a composition of G and F. So again you see, when Goff is defined, when first function is what? F. Range of F is the domain of G, then only Goff is defined. And in fog, range of G is a subset of domain of F, then fog is defined. Now you take some examples, and here also the thing I already written here, fog of x when I take, then it is f of g of x. So now take some example. Suppose f is a rule, f is a function, okay, f is a function from 1, 3, 4. F is a function from 1, 3, 4 to 1 to 5, okay, and g, let g is a function which is from 1 to 5 to 1, 3, okay. Then find, no, I taken only f is a function from these are the set, but rule is I not written. Now write the rule. F is equal to, suppose f equal to, when I take 1 is related to, suppose this f is a function from 1 to this set to this set. So you take the value of f like 1, 2, 3, 5, 3, 5, and next one is 6, 1. 1, 2, 3, 5, and one is 1, 3. Okay, so this is the example of 4, 1 also you can take, no issue. 4, 1. What is the rule? F is a rule. It is also relation. And one more thing, every function is a relation, but all relations are not function, but it is a relation. Why? Because these are the subset of this Cartesian product of these two. So f is what? F is 1, 2, and next is 1, 3, 3, 5, and next one 4, 5, and g equal to, you take 1, 3, 2, 3, 1, 3, 2, 3, and one more is 5, 1. Now find fog and Goff and fog. Now you find. So when it is possible, that I already told. Goff is defined only when, if, now you see first, f is a rule. Here this is also a relation as well as function. Every relation is not a function, but all functions are relations. And a relation which is called function when no two ordered pair having the first coordinate same. No two ordered pair having first coordinate same. If it is there, then it is not a function, it is only relation. Now Goff. For Goff or fog, I have to verify. I already explained when these things will be defined. So range of, first of all you find domain of what it is, f. So domain of f, first order sets, what it is, 1, 3, 4, and range of f is what? 2, 5, 1, 1, 2, 1. Second set is what? 1, 2, 5. This is what? Range. Range means second coordinate, the collection of second coordinate. This is the collection first or the collection of first coordinate is what it is, coordinate is 1 2, then first component is what, 1 3 4. So this is what, domain, and output is 2 5 1. So I just arrange that thing, 2 5 1, it is same. Now these are the domain of F, domain of G, and domain of G. Domain of G is what? Domain of G is 1 2 5. Okay. Range of G. Range of G is what? Range of G is 3 3 1. Means repetition not allowed in a set. So 1 3. So now you check GOF is defined or not. So what I written here, GOF is defined only when range of F is equal to domain of G. So range of F means what? 1 2 5, and domain of G is here. So you just see it is a subset or not. Why? Because all the elements of this set also present in this set. So here GOF is defined. Why? Because range is a subset of domain of G. Here range of F is a subset of domain of G. Therefore GOF is defined. Okay, so again you check GOF is defined. I having less space, so first of all I want to explain it is defined or not, then I will explain how to find this GOF and fog. See, regarding fog is defined when? Fog is defined only when range of G. So range of G is what? 1 3, and domain of F is what? 1 3 4. So see, every element of this set contained in this set or not? Okay, it is there. So here range of what it is, G, is a subset of domain of F. So therefore fog is defined. So in all the cases, in both the composition functions is already both the composition functions already defined. Now how to find GOF and how to find fog, that you see here. Now we have to find fog first. Like F is a function, G is a function, fog is a GOF is also a function. So I already explained, F is a function from this set to this set, G is a function from this set to this set, then GOF, it is a composition of F and G. So GOF is defined from this set to this set. You just see it a diagram. By diagram you just see first. This is what 1 3 4. This is what 1 2 5. This is F, and this is G. G is a function from 1 to 5 to 1 3. Okay, then composition of this F and G is denoted by GOF. So whatever the domain of F here, same domain we can take for GOF. So when we see 1 is related to, here F is defined, 1 is related to 2, 1 is related to 2, next is 3 related to 5, 3 related to 5, 4 related to 1, 4 related to 1. Okay, now G is defined from this set to this set, 1 3, 1 is related to 3, 2 3, 2 also related to 3, and 5 1, 5 related to 1. Then if I want to write GOF of 1, if I take, then see GOF of 1 means 1 related to 2 and 2 related to 3, 1 3. So GOF 1 is coming 1 3. You see here also, if I write in this way, G, it is called F of 1. So F of 1 is what? F of 1 is 2. So G of 2, and G of 2 is what? See, G of 2 is what? 3. So it is what? 3. So when we take GOF of, what input we have to take? this set. Why? Because GOF is defined from this set to this set. So this set, this having 1, 3, 4 element. So 1 I taken, next is 3 and next is 4. So just you take for 3, it is 5, 5, it is 1. So 3, 1 will come. So now you write G f of 3. So we can write this as G f of 3. F of 3 means 5. G5 is what? 1. This is 1. So again G f of 4 equal to G f of 4. F of 4 is 1. This is 1. And G of 1 is 3. So when we write GOF, then it is 1, 3. After that 3, 1, 4, 3. So these are the this is the answer for GOF. In similar way we can find fog also. See here. Now you see here fog. So for fog, what is the domain? I told domain, this is a composition of G and F. This is called fog. GOF is a composition of F and G. So what is the domain of F? Is similar to domain of GOF. Here a fog, when I write, then it is a composition of G and F. So what is the domain of G? It is similar to domain of fog. So domain of G is what? This 1, 3, 5. So we take 1, and for this I want to find what is the answer for 2 and for 5. Now you find what is the answer. 1 is related to, for fog means it is a composition of G and F. Like this you can take fog of 1 means F, G of 1. So G of 1 is what? G of 1 is 3. Okay, this is F of 3. So F of 3 is what? 5. This is 5. So 1 is related to 5. Similarly, if I take 2, then F is G of x, G of 2. This means F is G of 2 is what? 3. F of 3. F of 3 again 5. Why? Because 3 related to 5. Next is fog of 5. Why I taken 1, 2, 5? Because domain of fog is same as domain of G. Clear? Now what is fog of 5? So F, G of 5. So G of 5 is how much? G of 5. G of 5 is 1. This is F of 1. F of 1 is what? 2. So this is 2. So 2 related to 5 and 5 related to 2. F of 1 is 2. Okay. So 5 related to 2. 5 related to 2. This is the answer. So here GOF is there and here fog is there. So this is one example. Some more example you write. Now one more example. F is a function from R to R. R to R means real valued function, such that f of x is equal to cos x. Okay, and g is a function from R to R such that g of x equal to 3x square. Prove that GOF is not equal to fog. Means GOF of x is not equal to, it means just see, this is not equal to GOF of x not equal to fog of x. Okay, So now we have to check. First you find GOF and fog. So real, all are real number, real number, real number. Here real number, real number, real number, real number means that conditions here also applicable when GOF is defined, when fog is defined. It means here the proving is there. That means it is clear. GOF and fog is already existing. So we have to check the value is equal or not. So GOF. So GOF of, we take x. So g f of x we can write. So g of fx is how much? Cos x. G cos x. So gx is what? 3x square. So in place of x, this is cos x. So this is 3 cos x whole square. This is 3 cos square x. Don't put square on the angle. Now fog of x. F g of x. F g of x is how much? G of x is 3 x square, 3x square. What it is? Fx. Fx is how much? Cos x. So cos, see this is x. Suppose this is x. So fx. Fx is cos x. So cos x in place of x, 3x square. Okay. So here GOF of x, fog of x, both having different value. So therefore GOF of is not equal to fog. Okay. Some more questions you take. First you write first. Let f is a function from R to R and g is a function from R to R. Here also real number. Then such that fx, you can write here, f is a function from R to R such that fx, the value of fx is x square minus 3x plus 2, and g is a function from R to R such that g of x equal to what it is? F of x, and two functions are there now. So leave it only fx. So here f is a function from R to R such that fx equal to this. The find f of f composition f we have to find. F of f. So how we can see? This is called f composition f. That is denoted by f of f. F circle f. So how we can? F of x equal to f composition f equal to f of x. So what is fx? X square minus 3x plus 2. This is the value of fx. Now fx, this you take as x, capital X. So f of capital X. Again we write fx, that is x square minus 3x plus 2. Now you replace that value. In place of capital X, what we write? X square minus 3x plus 2 whole square minus 3x square minus 3x plus 2, and then plus 2. Okay, this one. So a minus b plus c whole square. This is x to the power 4 plus 9x square plus 4. Now ab, 2ab, 6 x cube, 2ab, again bc, 3 2 is 6, 2 is 12 x, and plus ca, 4x square, a square b square c square plus 2ab plus 2bc plus 2ca minus 3x square plus 9x minus 6 plus 2. So x to the power 4, and any q's there? No. Minus 6x cube square, here 9 and 4, 13, and you just solve here, so then it is 1, 10 10x square. After that x, the term related to x is minus 12 and plus 9. So minus 12 and plus 9 minus 3x, and then 4 and plus 2, 6 minus 6, cancel. So this is the value of F composition F. It is clear? Now one important question, it is of 1 mark. It's also for 1 mark question, very short type, because in 1 marks 3 categories: MCQ, fill in the blanks, and very short answer question. Now one in 1 word or 1 or 2 sentences you have to give that answer. Let next question, f is a function from R to R such that f of x equal to 3 minus x cube 1 by 3 power. Find f of f. You can say f of x. This you have to find. Now in similar way, that same question, so f of f x means f composition x. We write this as f fx. The value of fx is 3 minus x cube whole power 1 by 3. The value of fx. You can take this as capital X. So now it is f of capital X. So fx is this much, then capital Fx is what? 3 minus, in place of x, capital X cube whole power 1 by 3. Okay. If I take capital X here, then 3 minus capital X cube whole power 1 by 3. Now that capital X replaced by 3 minus x cube whole power 1 by 3. 3 minus, in this we can write x cube whole power 1 by 3, and this power is 3. In place of x I written only, and again this whole power is 1 by 3. So this equal to 3 minus x cube, because this power cancel, and 1 by 3. So this is 3 minus 3 plus x cube whole power 1 by 3. So x to the power 3 whole 1 by 3, that is x. So therefore f composition f of x equal to x. Now write fast. Over. Here one more question. Let f is a function from R to R such that f of x equal to x square. G is a function from R to R such that g of x equal to tan x, and h is a function from R to R such that h of x is equal to log x. Okay, find a formula, find a formula for H Goff composition H. You have to find a formula. Also prove that Goff of H circle Goff of root under pi by 4 equal to 0. This you have to find. Now see how it is. Very simple. Just see. First of all, you take it as h Gof. You put here x, means you can take it as, suppose this can take as a z of x. So z of x, now we can write this as h Gof of x in place of h o z, h o z, you see here h o z of x. So what we write? H z of x. So in place of z, Gof is there. Okay, so here h and Gof of x, again gf of x. Now gf of x, f of x is how much? X square. So gx square, and gx is what? Tan x. So h tan x square, and now tan h of x is log x. So log, in place of x we write tan x square. Okay, so here you have a formula, Gof composition h of x equal to log tan x square. Now what you have to prove? In place of x, when we write root under pi by 4, so Gof root under pi by 4 equal to log tan root under, place of x I written root under pi by 4, so it is pi by 4 because it is a square of root under pi by 4, then it is pi by 4, and tan pi by 4 is 1 and log 1 is 0. This is the required proof. Okay, write fast. So again one more question. Let f is a function from R to R such that f of x equal to x square plus 2, and g is a function from R to R such that g of x equal to x by x minus 1, x is not equal to 1. Find fog and Gof. Also find fog of 2 and Gof of minus 3. Gof of minus 3. Now how we can? So fog, for fog of x equal to fog of x equal to what? F g of x. This means f g of x is what? G of x means, what is g of x? G of x is x by x minus 1. So x by x minus 1, this is g of x. Okay, what f of x means? This is x minus 1 whole square plus 2. So this is x square by x minus 1 whole square plus 2. This is the answer for fog. And now what about Gof? Gof of x, g f of x. Gof of x means g f of x. G f of x means what? F of x is what? X square plus 2. Now what is g of x? So in place of x we have to write x square plus 2. X square plus 2. Here x square plus 2 divided by, here in place of x, x square plus 2 minus 1, then it is x square plus 2 by x square plus 1. Okay, so this is the answer of fog and Gof. One more question.